Hello friends. Having explained the meaning of minor, cofactor and adjoint, today we extend our analysis to explore the concept of inverse for a square matrix, otherwise also called the reciprocal matrix. Welcome to the video. As we have said, the concept of inverse or reciprocal matrix is applicable only for square matrix. Like the minor, cofactor and adjoint, which are applicable to the square matrices, the concept of inverse also is applicable only for square matrices. Now, for a square matrix A, let us suppose that there is another matrix B such that A into B or B into A produces an identity matrix. Then B is called the inverse of A. That is, if we multiply a square matrix with its inverse, it produces an identity matrix. So, we usually denote A inverse as like A to the power of minus 1. So, if we multiply a matrix A with its inverse, it produces an identity matrix. So, multiplication of a matrix with its inverse will obviously produce an identity matrix. Now, for a square matrix, the matrix inverse exists only for two cases, as we said. One, it's applicable only for a square matrix, and secondly, the matrix should be non-singular. That is, the value of the determinant must not be 0. If the value is 0, we already saw in the case of the types of matrices as well as the determinant. When the value of the determinant is 0, the matrices are known as singular matrix. So, the concept of inverse exists only for non-singular matrices. That is, those matrices having a non-zero determinant. A matrices in which there is no linear dependence or relationship between any of the rows and columns of the matrix. So, that is the idea behind the concept of inverse, also known as the reciprocal matrix. Inverse matrices are also called the reciprocal matrix. So, if we multiply a square matrix with its inverse, it produces an identity matrix. We will see an example a bit later. Now, how to calculate inverse? The formula for calculating inverse is A inverse equals adjoint of A divided by the determinant of A. So, for the calculation of inverse or reciprocal matrix, we need to calculate the adjoint of A, which we know that adjoint is nothing but the cofactor matrix as transpose. So, adjoint of matrix A divided by determinant of matrix A, and A inverse only exists when the value of determinant is not equal to 0. That is, if determinant is not equal to 0, we can calculate the inverse of the matrix. So, that is how we calculate the inverse. We will just put an example of certain numbers. Let me just erase this a bit. Let us explain the features of inverse or how to calculate inverse. Just we have a matrix like A equals, say, a 2 by 2 matrix, 3, 2, 1, 0. 3, 2, 1, 0. I have a 2 by 2 matrix. Now, first I need to check whether this matrix is singular or not, because for a singular matrix I am not supposed to calculate the inverse. Now, let me just calculate the determinant of A. Determinant of A will be equal to, we know that for a 2 by 2 matrix to calculate determinant, we just need to have some kind of a cross multiplication. 3 into 0 minus 1 into 2, so answer will be minus 2. So, the matrix is non-singular. So, we can calculate the inverse for this or reciprocal matrix for this particular matrix. Now, The first we need to have the cofactors. So just first we calculate the cofactors. Cofactor of 3 will be minus 1 raised to the coefficient of 3, which is 1 plus 1 into 0. So the answer will be 0. Cofactor of 2, which is equals minus 1 raised to 1 plus 2 into 1, which is equal to minus 1. Cofactor of this element 1, which is the coefficient of 1, which is minus 1 raised to 2 plus 1 into 2, which is minus 2. And I have finally the cofactor of 0. Cofactor of 0 implies minus 1 raised to the coefficient of 0, which is 2 plus 2 into 3. So answer will be 3. So the matrix of cofactors, we used to call it as Cij. Hope you remember. The matrix of cofactors Cij is 0, minus 1, minus 2, 3. 0, minus 1, minus 2, 3. So for the calculation of adjoint, we just need to have the transpose of this matrix. So adjoint of A equals Cij transpose, which is nothing but 0, minus 1, minus 2, 3. So I have the adjoint matrix. Now we can calculate, let me just erase this. Having both the determinant as well as the adjoint of this particular matrix, I can now easily apply what? The formula for inverse. What was the formula for inverse? A inverse equals adjoint of A divided by the determinant of A. We have already calculated the adjoint as 0, minus 2, minus 1, 3. We just remove this. Divided by the determinant. Determinant was minus 2. So answer will be, just solve this equation, the answer will be 0. Minus 2 divided by minus 2 is 1. Minus 1 divided by minus 2 is 0.5. 3 divided by minus 2 is minus 1.5. So this is the inverse. This is the inverse for a 2 by 2 square matrix. So our final solution is 0, 1, minus 5, minus 1.5. Now, this is how we calculate the inverse for a 2 by 2 matrix. You can easily extend the analysis to explore the case of 3 by 3 as well. The only difference is that for a 3 by 3, we need to extend the calculation of the determinant, and there will be 9 elements in the inverse or the adjoint matrix for a 3 by 3 matrix. So we have to divide each element, 9 elements of a 3 by 3 matrix, with its determinant. Now, just one more case. Having calculated the value of the inverse for our particular matrix, we can just explore whether if we multiply this original matrix with its inverse, whether it will produce an identity matrix. So let me just check whether this property is true or what. Now let me just remove this. I have the original matrix here and I have its transpose, right? Sorry, I have its inverse. So let me just multiply. I have the given matrix A into A inverse, because the A is already there, so I have 3, 2, 1, 0. Multiplied by, we have already calculated its inverse as 0, 1, 0.5, minus 1.5. Yeah? Just check whether this property is true or what. Whether the multiplication of a matrix with its inverse produces an identity matrix. Let me check it. So how to multiply matrices? We will multiply every row with a column and we'll add up the product, right? So A into A inverse equals 3 into 0 plus 2 into 0.5. Then 3 into 1 plus 2 into minus 1.5. Similarly, so the first row we multiply the first row first with first column, then first row with the second column. And now we will continue the analysis with the second row. 1 into 0 plus 0 into 0.5. 1 into 1 into 1 plus 0 into minus 1.5. So what will be the solution? 3 into 0 is 0, 2 into 0.5 is 1. So here we will get 1. 3 into 1 is 3. 2 into minus 1.5 is minus 3. 3 plus minus 3 produces 0. 1 into 0 is 0. 0 into 0.5 is also 0. I have 0 here. So 1 into 1 plus 0 into 0, minus 1.5 is nothing but 1. So we saw that once we multiply a matrix, so 1 0 0 1 is a 2 by 2 identity matrix. So once we multiply a matrix with its inverse, it produces an identity matrix. So that's the feature or peculiarity of the reciprocal matrix or an inverse matrix. So once more, an inverse matrix exists only for square matrix. Secondly, an inverse matrix exists only for a non-singular square matrix, that is determinant should not be 0. And once we multiply a matrix with its inverse, inverse is calculated as adjoint of matrix A divided by the determinant of A. Once we multiply a matrix, a given matrix with its inverse, it produces, as we saw, it produces an identity matrix. That's why it's known as a reciprocal matrix or an inverse matrix. Hope that these sessions are useful to you. So until we meet next time, stay safe, happy learning.